Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 938, range sum of BST. So it's a really easy problem to solve, and first we're going to go through the problem statement, then we'll check out the approach which you're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that we'll get a root of a binary search tree and two integers low and high, and we have to return the sum of all nodes with a value in the inclusive range low and high. Okay, so basically given a root node, we have to traverse that tree and we have to find the sum of all the nodes whose values lies between the two given variables low and high, inclusive of those values as well. So we can simply solve this problem using recursion. So that's what we are going to do. So this is the approach which we will be following over here. So these are the two conditions for the recursion. These two conditions are for the recursion, and we'll use this condition to get the final result. Okay, so the conditions are, we want to recursively process any node, the left side of any node, until it is greater than the lower value we have. Okay, next is the other condition in which we want to process the right subpart until the value is lesser than the high value which we have received. This right should have been high. Okay, so we are using negation over here, so that's why I said the logic the other way around. Okay, and we will add the value in result if it lies between low and the high, inclusive of these values. So let's do a dry run on this one. For example, for this binary search tree, the low is 6, high is 10. What we'll do, we'll have the root node. Okay, this is the root node we have. Okay, we'll get 10. Okay, 10 is, so over here we will see, like for the first condition I'm talking about, let's use some other color marker. Okay, so we will have 10. Okay, is 10 less than 6? No, right? So this condition will come true, and we will process the right the left subtree of it, right? Let's check the other condition. Is 10 greater than 10? No. So we will also check this one as well. Okay, now comes the result. So we'll have 10 in it because it lies between the range as well. Okay, next point is, next we will process 5. Okay, is 5 less than 6? No, right? 5 is not less than 6. So we will again check the other node, and so on and so forth. And if we follow the same exact condition and this rule, we will have 3 nodes which will be added to the result, which will be 10, 6, 7. Okay, because these nodes lies between the range of this, so it will be 10, 6 and 7. I think 23 will be the result of this. So let's check out the code for the same. So this is a simple code which I have already written, in which what we are doing, we have defined a variable result, which we saw in the explanation as well, and we have defined the DFS or recursive method. And what we are doing after that is, we are checking if we have received the correct node or not, like if the node is valid or not. Okay, if not, we will simply return 0. And then we have the 3 conditions which we talked about. If not node dot value is less than low, we would process the left subtree. If value is not higher than the high value, we will process the right subtree as well. And if the value lies between the range given, we will simply add that into the result variable which we have defined over here. Here we are just simply initiating the recursion with the root node, and at the end I'm just simply returning the value of the result. Let's check out the test cases. So as you can see, the test cases got cleared. Let's submit it for further evaluation now. And the solution got accepted, and as you can see, like, we have performed very well. We have outperformed 93.67% of the submitted solutions on runtime and 97.66% on the memory side. So yeah, this was the solution, guys. Thanks a ton for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.